me to do the coding for that. So after each short explanation, I will give you time to try on it. Okay, so when you click on LabVIEW, right? So this is the homepage of LabVIEW. So we are going to create our first project first. You guys can see my screen, right? Hello. Hello. Is anyone here? Can someone respond? Hello. Can see the screen? Hello. Okay. So create a new project. Okay, so we are selecting this blank project. Okay, you guys can try on it first. So this will be the project we are creating. Okay, then we are going to save this project. So we click on this file on the top left corner, and we save. Okay, just choose a folder to save. So let me press. Okay, then so this will be the project. So there are actually two parts in this project file. So when we go back to UTM, right? So I will teach you guys on how to use LabVIEW to connect to MyReal. So for currently, we are just using my computer only instead of MyReal. Okay, so click on this my computer and select new VI. We are going to create a file. Okay. So this VI file will be the file that we are storing our code. Okay. If I'm doing too fast, tell me. Okay. Okay, so there'll be two parts, right? So this one will be front panel. This one will be block diagram. So there's a shortcut here they can use. You press Control T to make it become full screen like this. Control T. Okay, so what front panel does here is, okay, you right click, you see all of this. So there are numeric, Boolean data container. So these are all the components that we can use. So our code will be writing in block diagram. So if you right click on block diagram, you'll see all of this. So numerate, Boolean, all of this kind of stuff. Okay, for example, if you guys have learned any programming language like Python or C++, then you guys should have no problem to do with LabVIEW. Just the concept is kind of similar. Just the it's not line of code, but become block diagram, like block. Okay. So there are also okay, there are data type in programming language, right? So same as this one. So there is integer, there is double, there is enum, there is boolean, true and false. There is also string. So these are all the common things that we are going to use later on in competition also. Okay. And also there is, if you can see here, there are add, subtract, multiply, and divide all of this. You can do mathematics equation here. And also here, comparison, compare. Boolean here, you can see AND gate, OR gate, exclusive OR, NOT gate, all of this kind of stuff. Now let's try on this one first. Okay, if we put a right click and you left click this one, select, and you just put it on this block diagram. Okay, it will become like this. So one of the disadvantage of this live view is you cannot zoom in. So the block is only this small. You have to kind of hard to zoom in. Okay, so when you put this on, you will see. Okay, when you move your cursor here, you can see 3 dots here, right? X, Y, and Z. Okay, so how do we do a simple addition? Okay, see the first dot right here, right? You right click on it. Okay, so there are 3 main things here that we are going to use. This one is a very important one. Okay, 3 things: constant, control, and also indicator. So constant and control is the input. The third one, indicator, is output. Okay, let's try the constant one first. Okay, if you click on constant, so it will become like this. It gives you 0. You can just modify on the number. Okay, if I want like okay, this number. This is constant. What if we try control? Okay, right click, create control. Okay, so you see there's something appear here. This one is the front panel. So everything is like this front panel is to display what you code are working on. Okay, so you can adjust the number here. After we run, then the output will come up. So this is control. Okay, another one we try 2 dots, right? It x plus y. So y will set it constant, make it constant. 20. Puff. Okay, so for output here, there's no way you're putting 2 input, right? Constant and control cannot, right? See. So what you must do here is to create a indicator. Okay. So this is the indicator. So this will be the simple addition in LabVIEW. So how to run is, can you see this right arrow here? Click on this. Okay, and then you will click. You will get the answer here. This is a simple addition in LabVIEW. Okay, there are so many things here. Okay, for example, okay, it's okay. Okay, can you guys see the top right corner here got a question mark here, right? If you don't know how to use this little component, right, you just click on this question mark, and then you point to it. Then it will show, this one, what are the 3 dots means, x, y, x plus y, like that. Okay. If I put this one, okay. Let's say you don't know how to use this. Okay, just click on this question mark, then you point on this, it will show. S is the input. When the input is true, then we will return the true value. If it's false, then it will return the false value like this. If you don't know how to use, then you can click on this question mark. It will explain to you. Okay, so far okay. This we are going to do 5 or 4 simple functions. Okay, if this one okay already, just leave it first. Okay, so now we try everything. Okay, we're going to build a function. The function will increase the value by 1 every time. It will keep increasing 1. That means increment by 1. Okay. try this increment. Okay, let's say if you want to find some function or some gate, you don't know where to find because there are so many functions here, right? Yeah, there is a shortcut you can use is control. Then you keep pressing control, then you press space. Okay, wait. Wait, where did no function? Okay, it's okay. Maybe I forgot. Okay. So for the increment one, okay, let's say I want to start with 0, put on 0, then increment by 1, the indicator. Okay. So this one will be okay. If you want to change the name of this indicator, right, you can just double click on it, then you rename. And can drag. Okay, if we run, it become 1. If we run again, it doesn't change anything because this one, right, is only run one time. So what do you do if we want the function to be want to loop the function? So we are going to use a loop for loop while loop. Okay, so for example, we are using while loop here in structures here. So you can click on while loop, then it will become like this, right? So you drag it to cover the function inside. Okay, come like this. Okay, so this one we are not using, so we are going to comment first. So in programming language, when you comment something, that means it will not appear in the code when you run the code. So in LabVIEW, there is a thing called structures diagram disable structure. So you can click on this and then cover this. So when I run the code, this function will not be working. Okay, so this is a while loop. The function is already inside. So you can see the run button right here is showing list errors, right? And run. So if there is any error here, we can run. Okay. So what happened? Conditional terminal is not wired. That means, okay, can you see this loop? Wait, sorry. Loop conditions here. So this one is the terminal point. We are going to right click on it, then we create a constant for him. So when it's false, the loop will keep looping. When it's true, then only it will it cannot loop because it's true. It's terminated already. Okay, so we are going to put false. So when we put false, okay, if we run, okay. So our code is just keep running. It will not terminate because the condition is false until we press the click on this abort. Okay, so we already put the while loop to this function. What is it? What is this number? Is still 1 only. Isn't it just keep looping, keep looping? Okay, so there's one thing in LabVIEW called shift register. So I would show you guys on how to do it. To be able to keep increasing the number. Okay, okay, not yet first. Okay, now can drag this 0 out of the while loop. So this will be the initial value because it's outside of while loop, right? Once the value, okay, yeah, it only goes in once, then the value will be just keep looping the loop. Anything you want to put? Okay, I put 1 here first. Okay, then we are going to connect this wire to the wall of this or loop. Become like this. Okay, now you see what's any difference? Okay, nothing difference, right? But the value increased to 2 already. Okay, let's try another time. Okay, nothing. It's the same, right? Because we haven't used the shift register. Okay, so what you should do here is you point on this loop terminal here. You right click. Okay, then you see this replace with shift register here. Click on it. Then put another shift register on another side here. Okay, the square one you should delete. Okay, then you left click to connect this shift register to the wire. So it will become like this. Well, let's try now. Let me make it bigger. You see, the value is increasing so fast. Why? Because the loop is keep looping and it doesn't have any wait time, or it just follow the program speed. Okay, what we should do here is you wait. Okay, right click, find this in the timing folder. You put this wait time. Okay, so what's the function of this is milliseconds to wait. So once the everything inside this loop has been executed, so it will have to wait how many milliseconds. Only then it will go to another iteration. So for example, here I put 1000 milliseconds, that means 1 second. And then we see what's the output. Okay, so this will be the output. The number is keep increasing by 1. Okay, when you are doing codes for the competition, right? The code is very huge and it involves so many things. So when you want to debug and you couldn't find any error in the program, right? You can click on when the program is running. You can click on this little bar, a light bulb here. It says highlight execution, so you can click on it. Okay, then you show every iteration, like everything that is running, it will show 42 plus 1, 43. So it goes like this. Then the termination here is always false. So the iteration will still go on. This one is to check anything in your code is got error. Okay, so this while loop, right? The condition is false. That means the loop cannot be ended. So now we want to try to end the code when this value become 10. So what we should do here, we're going to give, okay, it's kind of like other programming language. We want to compare. If this increment value is equal to 10, then the while loop should terminate. Okay, if this is equal to 10, right? So we find equal in comparison, right click, comparison. There's an equal here. Okay, drag, put here. So we want to compare this, right? Okay, move your cursor to here and you left click to connect these two. Okay, see this. X, Y. We are going to compare here, X and Y. If they are the same, then return true. If they are different, then return false. Okay. Let's say we want to terminate this loop when the increment value is equal to 10. Then we are going to put 10 here. So when the value is not equal to 10, this one will always be false. This line, initially like this, always be false. And the loop will keep looping. So when we add this, when the value is equal to 10, they will become true. Then only the loop will be terminated. Okay, let's try. Connect this. And we try to run. Okay, 2, 3, 4. Okay, it will be terminated. So there are so many things you can play with it. I just show you guys the basic one you are going to use later on. Okay, then okay. So we try another one. Okay, so you guys can see just now there are so many loops. Eh? Okay, 2 loops. 2 loops, and there's another one here. Time loop. Okay, so let me copy one first. So if I want to copy all this, you can select all this. Okay, there are 2 ways. The first one is you can just Control C, Control V, copy and paste. Another one is, okay, you're selecting all this, right? You keep pressing Control. Okay, you point to this structure component, and you keep pressing left click. Okay, so to duplicate this one. Now this one we are not using anymore, then we give it diagram disable structure. Okay. There's another loop that we do not need to compare this one. You can straight away give the number, then you can terminate. Okay. It's for loop. Okay, you click on this for loop, then you right click. Then you find this replace with for loop. Okay, if you guys know how to simple concept on programming, then you will know this for loop. For how many iterations it will loop. Okay, you can click on this replace with for loop, and then it will become like this. So you can see the terminate condition is missing. It has another thing here. It's called num loop count. Okay, so now we don't need to compare the value and the number we want to reach to terminate. So we can delete all this. Okay, when you delete components, right, you found this wire loose ends, right? If you don't settle this, then you cannot run. So there's a shortcut to clear all this by pressing Control B. Control B to clear all this no end wire. Control B. accidentally delete the indicator. Okay. The end here loop count here is the loop count that we want the loop to loop. Okay, if we put 10, we create a constant here. That means the loop will be looping only 10 times. Okay, let's try this one. Okay, so for loop here, we're looping 7, 8, 9, 10, 11. Okay, so because the iteration is start from 0, so it'll be 11. So if you want to see the iteration count, there's a dot here. You can see on the right hand side, you can right click on it. Then if you want to see something, indicator is output. So you create indicator. Okay, so you appear here. Hi. Okay, if you run, so 0 will be first iteration, then 3, 4, 5, 6, like that. Okay, so basically these are the two loops that we are normally using. Okay, it's kind of similar to the for loop. Okay, we're not using it. Disable first. Okay, so far okay. Okay, if nothing, then we can continue with the third one. Okay, so this time we are using Boolean. We try something interesting. Okay, you go to front panel, you right click, and you find this. I want this round LED. Okay, you put on it. Okay, you see the 4 dots here, you can adjust the size. Okay, let's say this size. Okay. Now, I want to build a function that every time I click on this button, this circle thing, when it lights up, they will count as 1. Lights up another time, they will second time like this. So it will keep adding if I keep pressing like this. Okay, so actually this one you can see the little arrow here is on the left hand side. So this one is actually an indicator, it's output. But now we want to make it to become input. So you point on this, you right click, you change to control. Okay, then you can see this little arrow thing will become on the right hand side. Okay. Okay, actually the concept is kind of similar. Okay, we put the while loop first because we want these functions to keep looping. Okay, if lights up mean Boolean is true. If it's not, then it's false. So I want to compare. If Boolean is equal to true, then +1 like that. And then we find it's equal. Then we connect to right click constant. Then we want to compare if it's true or not. Okay. If Boolean is equal to true, then it keep adding. So we can use the concept here, the shift register. So the function of shift register is every time you add 1 to the value, like it's 1 here, right? Increment of 1, so it becomes 2. So the 2 here, the value 2 here will be stored in this shift register. So when it goes to another iteration, the value will come up. So the 2 will come up here. Keep adding on 3. 3 store in shift register. The next register come up, then 4 like this. Okay, so we make 0 first, increment by 1. Okay, and then we connect 2 dots here. Connect this to the wall of the loop. Then we want indicator. So we can right click on this wire, then create indicator to show count. Okay, so if it's false only, then we will add. If it's not, it is. If it's true only, we'll add add the number. If it's false, then we are not adding. We are using the old value. Okay, this one we haven't changed, so we will right click on this to replace with shift register. Okay, so there's a thing. This one show right click, new find comparison, select this one. So the output should be this one, Boolean. Because we want to check if the Boolean is equal to true or not. If it's not, then false lah. Okay. Okay, so true and false here. So when this one is true, it will return the value t. It's written t here. So if it's true, then we will add. So we are going to connect this wire to here. And this one can delete already. Okay, if it's false, then we are going to use, we're not adding anything. We are using the old value. Okay, so this part is the part after we add 1. So we are going to use the part before we add. So we are going to connect this wire to here. So the upper part here is when the value is true. So the bottom one here is when the value is false, then we will return this. So this one will be the output. So connect here. Okay. So this is basically how it works. So why cannot? Then you need to check anything. So the terminate condition is not put anything. Okay, false. Okay, then we try to run. Okay, when it lights up, the count is keep adding, but this is not what we want because we want only each time we click only adding by 1. Okay, if we click again, false, not adding, true, keep adding. Okay, we are almost there, but this is not what we want. Okay, one thing interesting about Level is there are so many components here. So after this, you can explore more by yourself. Go. Okay, so we need to find one thing called, wait, where is it? Yeah, this one. It's value change. Put this out. So only if the current value is different from the previous one only, they will count it as 1. Okay, so there are two conditions when I confirm that. Okay, one is when Boolean is equal to true. Also, we wanna wait, let me put this. Okay. we want to check if the Boolean value changed already. Okay, then we connect this wire to here. If current value is different from the previous one, then it will return 1. It means true. If it's the same, then it will return false. So we want these two conditions to be compared. So we can delete this wire. Okay, I want if these conditions are true, only it will be true. So we are using AND gate here. Okay, Boolean. Okay, change of first call. Okay, we connect. Another one connect. Okay, so the output, we will bring this to the input here. Okay, then wait, sorry. Okay, save. I think we run. Okay, now 0, right? We try. Click. Okay, 1. Okay, it's not clear adding. Okay, let's see if how the code is working. We click on this light bulb. Can see everything. This one is true, but this one is false. So when you see the AND gate, okay, you can actually click on the wire. Oh, this one is too big to check. See, this is always false. Okay, let's try if I click. We went another iteration. I can't. It's becoming true. Okay, we click again. We wait for this to become true. Then this one become true already. So you can use this light bulb to track every movement of your code. Okay. If I keep clicking, then the count will keep increasing. Okay, so this is basically how it works. The function. So this is just the basic things. After this, you guys can just go to explore yourself. There's so many things here. Okay, so the loops we have done for the loops. Now we try on another one in structures. Okay, so this one we are not using anymore. Then we put the diagram disable structure. Okay, so now we are going to use this flat sequence. So its name is flat sequence. So the function is also same. So each one of this sequence, okay, you can actually add more. Okay, let's try. If you right click on it, then you will see add frame after. Okay, click. They become 2 frame already. So how it works is, first it will execute everything, every code here first. After the code in the first frame has been executed, then it will go to another frame. So will go like one by one. The first one is done only, then it will go to the second one. If the first one is keep looping or it hasn't done anything first, then it will not go to the second one. Okay, now I'm going to do a thing else. Okay. We put how many? Then we put 4 for Boolean. When I run the code, I want the Boolean to light up one by one. Okay, this one light first, then the second one light, then the third one, the fourth one, like this. Okay, what we are going to do here is, so there are 2 frames here, so we want 4. So we just right click, we add to 4. Okay, like this. Okay, there are 2 ways to extend this frame. One is you can just left click to drag this frame. Another thing is, another shortcut key is you can keep pressing Control and then you point. Okay, for example here, don't let the, okay, keep pressing Control and you keep pressing left click to drag like this. You can drag to any position. Okay. Okay, then the 4 frames, I'm going to put 1 Boolean for each frame. Okay, so this one is indicator. That means we need to input the value to the indicator to display it. You can see the little arrow is on the left hand side. Okay, so what we are going to do here is we are going to input the value. So the value here is Boolean. So we are going to find true. Or you just right click on it to create constant. Okay, what if you put the different data type? If, for example, you put a double constant, like this, it cannot be connected because it's 2 different data type. So the code here will be shown like this, and you know this cannot be done, then change to another one. Okay. Okay, so for example, I want this to be light up, so I put true for each. Okay. So we try to run first. Okay, it run only 1 time and it's so fast that we cannot capture anything because the program speed is very, very fast. So what we are going to do is we just use the same concept here. We're going to set the wait time so that we can see every Boolean lights up. Okay, so we can find right click timing and wait time. Let's say 500, 0.5 seconds. And we copy for everything, for every frame. Okay. Then we try to run. Okay. Ding, ding. Okay, so this will be the output. So the concept here, you guys can also use for the competition. It's very useful. This is the simple concept I am introducing to you guys, like this one. Okay, actually, this one, there's one value here, right? You guys can actually not to put so much through here. Can just drag this wire to connect to all this, like this. Okay, let's see by slow motion. I mean, this one, the highlight execution. Okay, we click on it, then we run. Okay, now you can see everything is dim and don't light up because the thing, okay, true. Then only it goes in. Then only it goes in. After the wait time, it goes in like this. After everything is completed, then only the program will be terminated because there's no loop here. Okay, what if I put okay, I don't want this. I put the while loop here. Okay, here. and the condition is always false. That means the loop is keep looping, it will not go out. So let's see what will be the output. Okay, then see the another tree will not be lighted. Okay, because the loop is keep looping here, so it cannot go into another frame. So only the first frame is done, then it will go to another frame. So when you are doing this, you need to be careful with this. Oops. Okay, so this is the flash sequence, the sequence structure. Okay, now the fifth one is the last one. The last thing I want to introduce to you is case structure. Okay, this one already I put a disable structure. Okay, same. It's in the structures folder. Here, case structure. Click on that and just drag it out like this. So what is case structure? If you click on question mark and put like this, that means you can see the input here, right? Anything input to here, okay, if you are doing for many condition, like the concept in switch in C++, there are so many cases. If the case, for example, case 1, then you execute the code in case 1. If case 3, then you execute the code in case 3 like this. It's more efficient than if else. And here, true, false. Okay, let's make a simple calculator. So calculator, it will have plus, minus, multiplication, and also division, right? So therefore, so I'm going to use a variable, data type called enum, because I want the value to be shown in string. Okay, so once you have drag it out, this one is the thing, and I don't want it to be constant. So right click on it, we change to control. I want to control it on this one, on front panel. So after you have converted it into control, okay, so you can see here, there's nothing inside this enum, right? So we are going to put things inside. So there are 4 things, right? So we right click on this enum and we select this edit items. Okay, it's kind of similar with array, but it's not array. Okay, so the first item I want to be at. Okay, sorry, so I insert 4 items first. Okay, 4 items here. So the first one will be 0, 1, 2, the value here. First item I want it to be at. Okay, double click on it, then you minus, multiply, divide. So after you have typed all this, oh, I don't want the first one. Wait. Okay, only 4 here, they will click OK. Okay, after you have done this, then you will see when you left click on it, they will have 4 options here you can choose. Okay, so the thing in this block diagram is this one. It's just on front panel and also block diagram different place. Okay, So we want to input this 4 value into case structure. It means we wanna build different codes for this 4 different functions. Okay. Math. Okay, so we connect this to this input. Okay, so automatically this one will be add minus, but it has only 2, right? Okay, it's okay. Okay, default 1, 0 means default. That means you can see here. Wait. The 0 values here is default. That means if the case is not in fall of this, it will just return 0. Okay, only 2 here, right? You can right click on it. Okay, you can see this case after. Click on it. Multiply will come up. So we have another one. Divide. Right click. Add case after. So it'll be 4. 4 different space for us to put the block diagram. Okay, so what I want to do here is I want to do math calculation with 2 number. Okay, we go to front panel here, right click, we move one numeric control point. Okay, another one, let's copy. So we make it X and Y. Okay, so for this, okay, so now we are going to do for the case first. So add, we find right click, numeric, we find add, input inside, minus, okay, multiply, it's okay. Multiply, divide, oh, it's okay. Okay, you can switch cases here by clicking the left and right arrow. Minus, subtract. Okay. See, every case has different workspace. Okay, for example, add here, we want to add this two, X and Y. So we just connect this two. We just drag inside to connect. And this one, the indicator, right click, create indicator, then we put outside. Okay, the reason why we don't put this SY and answer inside is because only one, then we can use for 4 cases. If we put inside, right, then we need to put 4 X and Y for 4 different cases, which is not efficient. Okay, just put outside. Control V to clear. Okay, so you can see this, there's a white hole of the square box here. That means we are not connect everything yet. Okay, connect this, connect everything, divide. Okay, once everything is done, then we can just try on it. For example, x5, y10, and we're going to do addition. and we try to run. Okay, the answer is here. Run. So we count 15. If we choose multiply, run. So we become like this. So we try to track the code. The light bulb. Add. Okay. Run. So add. It goes to add. It becomes like this. So based on the case, okay, for example, 10. 20 divided by 5. Okay, divide. It goes to divide case, then come out the output. Okay, so 4. The answer is correct. So this is the use of key structure. There's actually many use cases, but this is one of the simple one. So these are all basically common thing that you will need to know when you are doing for a competition. But when we go back to Ultima, right, I will teach you guys on how to use the MyReal. So that one is more important because you will need to use MyReal to connect the hardware, to control the hardware. This is just a theory and simple concept on LabVIEW. Okay, that's basically all the things that you have to know. Any question? Okay, any question you guys want to ask? So I wait for 2 minutes. Okay, if no, then our meeting until here. Thank you guys. So if you guys have any question, you can just PM me. Okay, thank you. Bye bye.
Thank you.